Everyone. Today we're going to talk about applications of quadratics. So in previous lessons, we've graphed quadratics, we've looked at different forms and identified important information like the vertex and the X-intercepts, the Y-intercept, the vertical stretch, does it open up, does it open down. Today we're going to take all that and apply it to real-world situations. The first thing we're going to do is we're going to attempt to warm up. So we're going to practice solving. Solving is still an important skill. We're going to need it in this lesson. So pause the video, solve the quadratics using any method you'd like. And remember, we can factor some of them. We can use quadratic formula for some of them. Some of them, we can just use undo steps and get x by itself. When you're ready, you unpause the video, and we'll check at the answers. Okay, so you've made it through the three of them. Took you a few minutes. Feeling more confident. Maybe there's some you still got questions on. Okay, this first one and all of them, we would like one side equals 0. First one's factorable. So you set each factor to 0 and you could solve. The middle one, I did something a little different. I saw there's two terms, so I added 18 to both sides. And then I divided by 2. We could have also factored out the GCF and did a difference to squares problem. Or for all of them, you could still do quadratic formula. But in this case, a equals 2. There is no b, so b is 0 and c is negative 18. And if you want to use quadratic formula, you can do that. Third one I also factored. As the numbers get bigger, I tend to lean more towards using quadratic formula. And if you have a graphing calculator, it'll convert to a fraction. If you put a decimal, that's okay too. Now today, only new terms are the maximum and the minimum, which relate to the vertex. So if I can graph it, I know the vertex. If the parabola opens down, the vertex is the highest point, which is called the maximum. If the parabola opens up, then the vertex is the minimum. And then the initial condition, we're going to see situation problems today, word problems, where it says, what's the starting height? Where do I begin? We need to interpret each point on the graph as a real-world item, a real-world time, real-world height. So let's get into looking at some of these. Okay, quadratic word problems. There's certain phrases. Any problems that generally deal with gravity are quadratic. Maybe you took a physics class and you learned that there's a negative 1/2 at squared. Okay, that when I see x squared or t squared, I know that we're dealing with quadratics. Now, 3 or 4 of the most important questions that I've seen asked. What's the initial height of the object? How long before the object lands? Or how long was it in the air? Those two are really the same question, but they can ask it in a bunch of different ways. Or what's the max height? How high did the object go? So each question, we need to think about what does it look like on a graph, and then how do I find that information from the equation? So we'll start with initial height. Okay, the question it's really asking is what's the y-intercept? Okay, because I start here. Okay, I start on the y-axis, and sometimes I don't start on the ground. Maybe sometimes I throw something off the top of a building. Or I throw something at head height. Okay, my head's not on the ground, so the starting height might not be 0. How long before the object lands? Or how long was the object in the air? Really, we want to find what the x-intercept was. Because if I have an item that I take and I throw, and it lands, I want to know what this horizontal distance is, the time. So this x-intercept, this one right here, tells us, well, at that many seconds, it landed. Now, what's the max height of the object? Okay, I want to know the vertex, but more specifically, I want to know the y-coordinate. So once again, I got a parabola that goes like this, and it lands. I want to know what the y-coordinate is. I still got to find the whole vertex, because we've learned how to find the vertex. But if I can tell you the y is generally the height. X a lot of times is the time. So maybe I ask you at what time did it reach the maximum height? So that would be the time for the x, and then the y would be the height. So step one, whenever I see a word problem, is what is the question asking, and what's the math I need to do to answer the question? Let's take a look at an example. We'll break it down piece by piece. We'll look at the important phrases and the important numbers and how to go about it. So sometimes I like to dream that I'm a really good golfer. Not accurate, but I like to dream. So let's say I'm at 5 under on the first 3 holes, meaning I have had a really good round. And on my 4th hole, I hit my shot, and here's the function that measures it. So the height of the ball over time is given by this function, negative 16 t squared plus 64 t, where t is time in seconds and h is the height in feet. And I want to ask 3 questions. What's the starting height? How long does it take for it to hit the ground? And what's the max height? So these 3 are the same 3 that we just looked at in the previous slide. So first question, what's the starting height? I like to graph this or make a rough sketch. Okay, I know that it's in standard form, so my C value is 0. I hit the ball, it goes up, and it comes down. Okay, now I can put 0 in for x, and I can solve for y. Or in this case, I put 0 in for t and solve for h. So the height at 0 seconds is 0. 0 squared times something, 0, lots of zeros. So it starts at 0 feet. Okay, which is okay. It makes sense for a golf ball. Okay, hit it off the ground. Now, how long does it take for the golf ball to hit the ground? I want to find the X-Intercept. Okay, I saw that my graph starts at 0, 0. But now what's my next intercept? Now we remember how to find X-intercepts. Okay, we set y equal to 0, and we solve. Now I've got multiple methods to solve this. We could use quadratic formula. Maybe we could factor. Maybe factoring works really nice. I'd say look at factoring. If the problem looks really scary, just go straight to quadratic formula. But I've seen 16 and 64 before. So what I factored out is negative 16t. So I have 2 factors. And from this, I got 2 really nice intercepts. Now this is not going to happen frequently, but if it's really quick to factor it, I would do so. So at 0 seconds, I'm on the ground, which I already figured out before. And then I get at 4 seconds. So I know that the ball lands at 4 seconds. Well, it takes 4 seconds. The ball's in the air, has a hang time of 4 seconds. Now the max height. Looking at the graph, the max height, we know it's called the vertex. If you can compare names and liken vocabulary to real world ideas, then we know what to do. You've found vertex for a while. Okay, we got to find this vertex. We now know that since it's in factored form, the vertex is in between 0 and 4. Or we could do negative b over 2a. So x equals negative b over 2a. So negative 64 over negative 32 is 2. But I want the height. The x is, or I should call it t. So t at time at 2 seconds, it hits the height. Now I got to find the height at 2 seconds. So I got to do h of 2. So the height at 2 seconds is 64 feet. So just ask what the maximum height is. I went and gave more information, which depends on what the problem asks. Might be a good thing, might be a bad thing. Max height is 64 feet. Okay, now if I wanted to put together this graph, I got 3 good points. If I wanted to make a nice sketch, I have 0, 0, because it starts at 0, and it lands at 4 feet. And then at 2 seconds, it says 64 feet. Maybe they want you to make a sketch as well. But each problem tells you a specific point. Do I want the X-intercepts, the Y-intercept? Do I want the vertex? And we've practiced using the properties of quadratics. How do I find each one from an equation? Now it's your turn. So Olivia decides to play with fireworks. She discharges fireworks from a height of 4 feet above the ground. The path of the fireworks is given by a height function, negative 16t squared plus 160t plus 4. This negative 16t is due to gravity, so you're going to see negative 16 a lot out front. T is time in seconds, h is height in feet. So the 2 questions you got to ask. Where on the graph are you going to find the starting height? What's that called? And when will the remains hit the ground? What's that called? And then if you want to find the actual numbers, you can do that too. But right now, where should your eyes be looking? Where should we think about? Which points? Pause the video. Think if you can do this. Okay, so let's take a look. So the starting height is the y-intercept. You put in 0 for t. At 0 seconds, you're at 4 feet. So maybe she launched it off of a table, or hopefully she didn't just hold out her hand at 4 feet and launch fireworks from her hand. Launching fireworks just seems like a terrible idea, and I just like watching fireworks, not actually lighting them. Now, when will the remains hit the ground? The X-intercept. I'm not factoring this. As I said here, I'm going to use quadratic formula. I do negative b plus or minus square root of b squared minus 4ac divided by 2a. I take my time. I'm very careful. And I get 2 answers because I get the plus answer and the minus answer. So in this case, I want the positive answer. So the remains hit the ground after 10 seconds, so 10.025 seconds. Okay, this negative 0.025, let's look at what it means on the graph. Since she started at 4 feet, this is the trajectory of the fireworks. Now there's a little part back down here, okay, that doesn't actually exist. So that's what I'm pointing to with the arrow. This is not actually part of the situation, but if I graphed the whole function, it would keep going down through the ground. It would go before the beginning. So what I have as dashed parts of my parabola aren't really the full extent of the graph. Oh, they're really the full extent of the graph. I only care about the part from start to finish, though. Now, last one for you to try today. Here's a rocket problem. I want you to read it. I want you to pause the video. I want you to try answer all of these questions. Pause the video, take as long as you need so you understand it. Okay, so here are some answers. Okay, maximum height. I want the y-coordinate of the vertex. How long until impact? I want to know when g is 0. So when the height is 0, what is the time? So the positive one, that's 9.571 seconds. And then why are we shooting rockets? I don't know. Okay, I pulled this problem because when I used to learn, some of the textbooks that I learned from dealt with Soviet Union problems and United States and Soviet Union shooting rockets at each other. Kind of morbid stuff, but I like to see rocket problems generally fall under the quadratic functions unit. And now you know how to apply quadratics. So if you're given a situation, you can find the max height, or you can find the starting height, or you can find how long it's in the air based on the equations and using the calculations that we've done.